Hi class, this section is 3.1. It's on quadratic functions. So first things first, they want us to graph this quadratic function. So when it's in this form, this standard form, we need to find the vertex first. We can do that by using the formula. So here's the formula, x equals negative b over 2a. So a is 3, it's the coefficients, b is 6, and c is negative 1. So if we plug in the values, you're going to get negative 6 over 2 times 3. It's going to be negative 6 over 6, which is negative 1. We still have to find the y-coordinate. So to find the y-coordinate, we plug the x-coordinate into the function, and we should get 3 minus 6 minus 1, which is negative 4. And we can see that here, negative 1, negative 4. That's exactly what the vertex is. And so we can write that here, negative 1, comma, negative 4. The x-intercepts, they seem to be 0 and negative 2, but we don't want to assume that that's the case. So in order to figure out if that's exactly what it is, we should actually apply the quadratic formula. So x equals negative b plus minus square root of b squared minus 4ac all over 2a. So that's going to be negative 6 plus minus 6 squared minus 4 times 3 times negative 1 all over 2 times 3. So it's going to be negative 6 plus minus 36 plus 12 over 6. And then that's going to be negative 6 plus minus, what is that, 48 over 6. So let's see, we are going to get radicals here, irrational zeros. So that's going to be what, 16 times 3. So 16 times 3 is 4 radical 3. All right, and then we can simplify by a factor of 2. So 2 goes into 4 twice, 2 goes into negative 6 negative 3 times, and 2 goes into 6 3 times. So our final answer would be negative 3 plus 2 radical 3 over 3, and the minus. All right, so those are the two x-intercepts. So we want to place that, the smaller one would be this one because it's got that minus. So this will be the smaller, this will be the larger. So the smaller one goes here. So that would be negative 3 minus 2 radical 3 over 3, comma 0. The other one would be negative 3 plus 2 radical 3 over 3, comma 0. And the y-intercept, well, for the y-intercept, all we got to do is plug in 0 for x. If you plug in 0 for x, you're going to get minus 1. So 0 minus 1 is our y-intercept. All right, select maximum or minimum value. Because this parabola is opening upward, that means it's got a lowest point, which would be a minimum value. So you would write minimum, or you would select minimum. What the value of f is, the minimum value of f is f of x equals, it's the y-coordinate of the vertex, which is negative 4. Find the domain and the range. Well, the domain refers to how far left and how far right the graph is defined. As you can see, this parabola is just going to get infinitely wider in both directions. So it's going to go infinitely that way and infinitely left. So the domain would be all real numbers. And the range has a lowest value of negative 4, and it continues in the positive direction indefinitely. So that's going to be negative 4, close bracket, because it's actually touching, all the way to positive infinity. All right, this one they want us to express this in standard form. So standard form is when you have it in this form here, where h and k is your vertex. All right, so let's go ahead and do that. So the first thing we should do here is, well, you can this is the way I recommend doing it. I would recommend doing it the same, similar to what we did in the previous problem, is negative b over 2a to find the vertex. So that would be negative 4 over 2 times 1, which is negative 2. Plug in negative 2 to get the y-coordinate. It's going to be 4 minus 8 minus 3, which is negative 7. All right, so that's your h and that's your k. So going back to that form that I had written, we can now plug that in. And it turns out that a is the same as this a, which happens to be 1. So that's just going to be 1 x minus h. Well, h is negative 2, so minus a negative 2, that's a double negative, which becomes plus 2. And k is negative 7. So that would be our answer. X plus 2 squared minus 7. All right, the vertex, we already found that to be negative 2, comma, negative 7. The x-intercepts, well, this looks like we can factor this. If you factor it, you're going to get x minus, let's see, is that factorable? Actually, I don't think it's factorable. So you can set this one equal to 0 and solve, or you can set this one equal to 0 and solve. I would recommend setting that one equal to 0 and solving. It's a little easier. So if you solve that, you're going to get plus 7 plus 7. You're going to get x plus 2 squared equals 7. Square rooting both sides gives us x plus 2 equals plus minus radical 7. And then subtract 2 to both sides. So you end up with x equals negative 2 plus or minus radical 7, which is negative 2 plus radical 7 and negative 2 minus radical 7. So those are the two x-intercepts. The smaller one goes first, and the bigger one goes second. Right, and the y-intercept, for that we simply substitute 0 in for x. When you do that, that becomes 0, 0. You're left with negative 3 as your y-intercept. So now the sketch, well, let's draw our coordinate plane. I would recommend that you figure out what these are in decimal form so that you have an idea of where they should go on the x-axis. So I'm going to do that now. Convert those into decimals. So that's going to be negative 2 minus radical 7 is equal to, this is going to be, this one's going to be negative 4.6 approximately, and the other one's going to be positive 0.65 if you round. So the two intercepts would be so one of them would be positive 0.65, which is about right here somewhere. The other one's going to be negative 1, 2, 3, 4.6, about right there. And our vertex would be negative 2, negative 7, 1, 2, 3, 4, 5, 6, 7. So it would be way down here somewhere, approximately. So that's the way our parabola would look, approximately. A quadratic is given expressed in standard form. So same thing, let's go ahead and find our vertex first, which is negative b over 2a, which would be positive 6 over 2 times 3, which is 1. If we plug 1 back into the function, we're going to get 3 minus 6 plus 1, which is negative 2. All right, so that would be that. All right, so, and then we remember, we know what a is. It's the same a as this a. It's 3. So ax minus h squared plus k. This is our h, and this is our k. So our final function will look like this. A is 3, because it's the same coefficient as this a. and then x minus h is 1, and then k is negative 2, so that should be minus 2. All right, so that should do it right there. So that's 3x minus 1 squared minus 2. And then the sketch will look like this. All right, well, we do have to find the intercepts again. So if you set this equal to 0, that's how we can find the intercepts, the x-intercepts. So add 2. Divide by 3. Take the square root of both sides. Plus minus radical 2/3. And then finally add 1. So let's get the decimal approximation. Let's do the plus 1 first. I'm getting 1.86. I'll just call it 1.8. And then if I do the subtraction one, I'm getting 0.18. All right, so here is the graph. So the two intercepts are 1.8, which is about right here, approximately. And the other one's 0.18, which is approximately right there somewhere. And then the vertex is 1, negative 2, which would be here. And there's our parabola. All right, moving on to the next problem. A word problem says if a ball is thrown directly upward with a velocity of 24 feet per second, its height in feet after t seconds is given by this function. What is the maximum height attained by the ball? Well, notice that this is a quadratic because it has a square term, and notice that it's opening downward because the leading coefficient is negative. The quadratic term is negative, so the parabola is going to open up this way, which means it has a maximum value which represents a height. So we need to find this vertex. The y-coordinate will tell you how high the ball reached. So the vertex, once again, is negative b over 2a. This is your b is 24. Your a is negative 16. So if you plug that in, you're going to get negative 24 over 2 times negative 16, which is negative 24 over negative 32, which is approximately 0.75. And now we plug that into the function to figure out what the height is of the ball. So t becomes 0.75. 0.75 minus 16 times 0.75 squared. So I just plugged in 0.75 for t, and that's how I'm going to get the y-coordinate, and that tells you the height. All right, so 24 times 0.75 minus 16 times 0.75 squared is 9. So that is the maximum height that the ball reached, 9 feet. All right, the last problem is very similar. They give you a manufacturer finds that the revenue generated by selling X units of a certain commodity is given by this function, the revenue function, and it's measured in dollars. What is the maximum revenue and how many units should be manufactured to obtain this maximum? Similar as the previous problem, the quadratic term is negative, which means it's going to open downward, which means it has a maximum value, which represents the maximum revenue in dollars. So that's what we need to find. So let's once again find the vertex. In this case, our b is 60, and our a is negative 0.5. So that's going to be negative 60 over 2 times negative 0.5, which is positive 60. All right, and now to get the y-coordinate, we'll plug that into the revenue function, which is going to be 60 times 60, minus 0.5 times 60 squared. Let's see what that is. Getting 1,800, which represents dollars, and that is going to do it. So this would be the dollar amount, and this is the units sold. So they sold 60 units, and they made $1,800 maximum. That concludes this section.